Today we will be looking at energy sources. Now, I will go ahead and let you know there are a couple of buzz-in games that we will not be able to play, so you can just kind of ignore those slides as they come up. But let's go ahead and look at our traditional and alternative energy. So where do we get our energy from? We are looking at the energy that is fueling our cars, fueling your phone, the computer you're looking at right now. Where does all that energy come from? Well, we have two main categories of energy. It can come from either a renewable source or it could come from a non-renewable source. Renewable energy are sources that will replenish, meaning they will come back in a relatively short amount of time. Non-renewable resources, they technically will come back, but they take so long to come back that you'll never see them again. So, for example, if you cut a tree down, a tree will grow back within your lifetime. So that would be considered a renewable resource. The non-renewable resources, something like oil, that is going to take hundreds of thousands, if not millions of years to come back. So you will not see that resource again. So here's just a couple examples. So coal would be a non-renewable. Trees would be renewable. Oil, non-renewable. Gas, non-renewable. Chicken, that is renewable. If I eat eggs this morning, I will get more eggs back within my lifetime. Chickens replenish within a short amount of time. And then gold. So your precious metals, things like that, sometimes they call them ore, O-R-E. Those precious metals, those are all non-renewable because they do, again, take many, many, many years to form again. So first we're going to look at our traditional energy. Traditional energy sources are all non-renewable resources. So if you are talking about traditional energy, you are in fact talking about your non-renewables, and those non-renewables are also called fossil fuels. So there's basically three names we could give them. So non-renewable energy are our three fossil fuels, and those three fossil fuels are coal, oil, and natural gas. The reason we call them fossil fuels, and maybe you'll understand this little cartoon I have to the right, is because they came from the same time that dinosaurs were around. So a dinosaur could have died, and then its matter would have turned into the fuel that we are using now. So it took millions of years for that dinosaur's remains to become the oil or gas that we use. And I'll tell you exactly how that happens later. So fossil fuels are made from biomass formed from the remains of both animals and plants. It doesn't have to be a dinosaur. Dinosaurs are typically just what we use as an example because it gives you an idea of how long ago this biomass was around. And it was all from millions of years ago, and that's why they call it fossil fuels. So here's a review question. So what kind of rock do fossils usually form in? Well, that would be a sedimentary rock. Remember, sedimentary rocks compact and cement, and so that therefore they wouldn't destroy any of the remains. So that's where we'd find most fossils. Okay, so coal is the first fossil fuel that we are going to look at. Coal produces about 40% of the world's energy. That's almost half. So most of our energy comes from coal. Coal is mainly used for electricity, but they also use it a lot in iron and steel production. So we mainly use it for electricity, but the main thing to know is most of our energy comes from coal. That's the biggest thing to know from this slide. Another review, true or false? Non-renewable resources do come back. Is that true or false? That would be true. Technically, they do come back, but it's going to be a million years before they come back. That's why we call them non-renewables. So how do we use coal? Well, if you've ever seen the cartoons where you have the two people on the train and they're shoveling coal into a furnace to burn it to fuel the train, that's basically what we do. So you get coal and they grind it up into a very fine dust, a powder. They then put that powder in a broiler, kind of like an oven, and that will cause that the coal to combust and turn into fire. That flame will heat water, which creates steam. So the main thing we're using coal for is in order to burn it. Now, not all fires are the same temperature. Some fires are much warmer than others. Heat is energy. So the hotter a flame is, the more energy that it contains. Remember, energy is not created or destroyed, it's just transferred. So what we are doing is we are burning the coal into flame, and that's transferring the energy from the coal into the fire. The flame from the fire turns water into steam. That's another transfer. And what happens with that steam is it goes into these tubes and it turns a turbine. And so the energy from the steam is now going into the turbine that's turning, and that powers a generator. So something that you're going to notice with every single energy source we talk about is there's something that turns a turbine that powers a generator. That's going to be a common theme. In this case, we burnt coal, the steam turned turbines, and that powered the generator. So that's how we got our energy from coal. Let's keep going. Something you need to know about coal is it releases a lot of sulfur and carbon dioxide. Now, if you've ever smelled sulfur, it's got a very particular smell. It smells like rotten eggs. But coal burns a lot of carbon dioxide into the air, in which that's a very big issue. To battle this issue, there are a lot of power plants that have what we call scrubbers, and they help to remove the pollution created by the burning the coal. But it doesn't remove everything, so it is not perfect. So how do we get coal in the first place? Well, it's got a few stages of production, and I want to throw out charcoal is not coal. Those are two very different things. We call charcoal because it looks like coal, but it is not the same thing. So the first, where our journey begins for the first stage of production of coal is in a swamp. So millions of years ago, in a swamp, you had these dinosaurs and different animals. You got these giant cockroach things, and you've got different plants. And so it all starts in a swamp. So that's the big thing to note. Coal begins in a swamp, okay? That's the key thing. Those living things in the swamp, they then die. And when they die, they sink to the bottom of the swamp, where they are then buried. And as they are buried, you have a lot of heat and pressure. And over time, and when we say time, we're talking hundreds of thousands, if not millions of years, that heat and pressure will turn that biomass into coal. The first thing that it becomes is something called peat, P-E-A-T. So peat is the first stage of coal formation. Later, you have more time, more pressure, more heat, and eventually that will then turn into coal. So you have a swamp. You have all these living things. Some of the living things die. They sink to the bottom of the swamp. They're buried. Heat and pressure plus a lot of time creates coal. So peat is the early version of coal, and this is actually what it looks like. It looks a lot like dirt. And peat is technically considered renewable because it doesn't take as long to form. However, it doesn't have nearly as much energy as coal does. So although peat is technically renewable, it will only get you maybe a quarter of the energy that one piece of coal would. So how do we get coal? We get coal by coal mining. And there's two ways that you can mine land. You can either do surface mining or underground mining. If you do surface mining, it looks a lot like this picture to the left. You notice when you look at this picture, there are no trees, there's no vegetation. So in order to get this the coal out of the ground, you have to completely destroy the land. You take away all the vegetation, you strip it down, and that's what we call scarring the land. Because technically, you will end up being able to get plants to grow back here, but this land will never be the same. It will never be able to produce the same thing it could have before you had destroyed it. So that's one of the negative things for surface mining. If you do underground mining, you keep the ecosystem, you keep the vegetation. However, you now are going to be around a lot of fumes. It's very dangerous. It's very toxic. So they both have a big downside. Now, with every single energy source we talk about, we're going to be looking at pros and cons. So the pros, we'll start there. The pros of your coal is it's the most abundant fossil fuel. So there is more coal that available to us than of any other fossil fuel. So that's a big deal because we use a lot of energy in this world. Coal is also cheaper than all the other fossil fuels. So it's abundant and it's cheap. It also can be safely stored. Now, if you have an oil spill, that's a big worldwide cleanup. But if you have a coal spill, that's no big deal. It's just a couple rocks fell out of a bin. You pick them up, you put them away, and you're good to go. So it can be very easily stored and safely transferred. Now, the cons, these are the downsides, okay, the negatives. Coal is non-renewable. That means once we use it up, it's gone. So almost half of the energy in the world comes from coal. And once we use all that, we have no more. So that means we would need a new energy source to cover half of the energy used by the world today. That's a really big demand. Also, the fact that you scar the land when you get coal, that's a big negative. It's the dirtiest of all the fossil fuels. So the things I'm underlining are the biggest deal. So it's the most abundant, it's the cheapest, it's safe. However, it's the dirtiest fossil fuel. And that's one of the biggest negatives for coal. This is just a little cartoon that I think is funny. Because Santa, if you're bad, he gives you coal, and now global warming has melted the whole North Pole, so he's regretting that. I think it's kind of funny. Hopefully you get it. But let's keep going. Natural gas. This is our second fossil fuel. Natural gas is mainly used for electricity, and that's because it burns very, very hot. When you look at this pie chart, it shows you what all we use the natural gas for. Now, a lot of people think, oh, we'll save all the fossil fuels if we can simply carpool and drive less. And yes, that will help. However, look at this little section, that little teeny black line that you see there. That is the amount of gas that goes for vehicles. The rest of it is going for our electricity. So if you really want to save fossil fuels, you need to turn lights off when you leave rooms and things like that. Or, stay off your phones and just don't use as much energy in general. Like coal, what we do with our natural gas is we burn the gas. The heat from the gas the heat from burning the gas heats water, creating steam. The steam turns a turbine, and that powers a generator. And look, we have another review question. Peat is the same thing as coal, true or false? That is false. Peat is the first stage of coal, but it is a different thing. So oil and gas, we're going to talk about how they're made, but we're going to talk about how they're made at the same time to save time because they essentially are made the same way. So coal started in a swamp. Oil and gas are going to start in an ancient sea, aka an ocean. So if you picture Plankton from SpongeBob, he lives at the bottom of the sea. So here's my little Plankton guy. I think he has antennas, I don't remember. So imagine Plankton from 1,000,000 years ago. He dies in the bottom of the sea. He gets buried at the bottom of the sea. And over time, heat and pressure, not as much because it doesn't turn into a rock like coal, but it will end up turning that organic living matter that matter into either gas or oil. Gas and oil are typically found very close to one another. If you look at this picture, you can see the gas in yellow and the oil is black right below it. So they're formed a little bit differently, but the same thing as far as it was an ocean, organic matter or living things died, they were buried, and over time they turned into either oil or gas. And then we get it for our energy needs. So how do we get gas? We get gas through a process called fracking. That is a way, there are many different ways to drill for gas. Fracking is just one of them. I highly recommend you watch this video. It explains why it is that fracking is such a downside. I can kind of summarize for you. Basically, fracking creates a ton of water pollution. It uses up a just insane amount of fresh water. It then pollutes the fresh water to the point that it can never be cleaned again. And what we do with that extremely contaminated water is we just bury it underground. And then we hope that that water never leaks into our underground water that we use for drinking. Remember, half of all drinking water comes from groundwater. So if this did get in our drinking water, that's a very big deal. Now, not all drilling processes are as dangerous as fracking is. However, we've used up all of the easy-to-get-to gas resources, and now we're having to use these much more risky processes such as fracking in order to get the gas. And it's just a very bad process in all. Okay, let's keep going. Pros and cons. The pros or good things about using gas is it's very efficient. So this is one of the most efficient fossil fuels. It's the cleanest burning, so that's a very big deal to know. I'm going to put a little star next to it. Coal was the dirtiest, most abundant fossil fuel, but gas is the cleanest fossil fuel. There's less chance of a large-scale cleanup, so less chance for cleanup, and that's the big positives. The downsides, it's not renewable. So again, when it's gone, it's gone. It's also very flammable. Gas, if it catches on fire, you're going to get a big explosion. That's a very bad thing. And then also fracking. Fracking is very dangerous and leads to a ton of pollution, and we really don't know, because it's so new, the effects it's going to have on us down the road. Fun fact, natural gas is actually clear and it has no smell. A lot of people talk about how they like the smell of gas. Well, the next time you go, don't ever smell it because it's not good for you. But the next time you go to the gas station and you do happen to smell gas, that is not a natural smell. That's actually a man-made smell. They put that smell into gasoline and they put the color into it because if you ever had a gas leak, it's very dangerous and they want you to be able to identify it. So they try to make a very unique smell so that way people would be able to know right away, that's gas, I need to exit the area or clean that up or whatever it is that they need to do. Okay, and the last of our fossil fuels is oil. Oil is the world's most versatile fossil fuel. Versatile means it can be used in a variety of ways or just many different ways. It's going to be used in many different ways for many different things. This picture is just showing you some of the things we use oil to create. We not only use it in vehicles, but we use it to make all plastics. So your shoes probably had oil in it, watering hose, lamps, glasses, inhalers. Oh, this is what I use a lot, pacifiers, CDs, which are kind of out of date nowadays, but tape, cords, all that stuff, oil was made. Ladies, your makeup, oil was made or used in the production of all those things. So if we use up oil, we not only use up our energy source for it, but we also have to find a different way to make all of these products that we use on a daily basis. Pros for oil, it's very versatile. You can use it in so many different ways. Cons, it's non-renewable. So again, when it's gone, it's gone. Just like with all fossil fuels, they all release a lot of carbon dioxide, which leads to global warming. Oil is known for oil spills. And those are very difficult to clean up. I'll give you an example of that. And then also it's very expensive to find oil reserves. So all of that is one or reasons why oil is downside and we need to figure something else out. So Deepwater Horizon, this is a real thing that happened. Mr. Whittington was actually part of the Coast Guard that helped the cleanup of this. And this is and there's a movie. It's a very good movie. I do recommend it. And this is the preview for it if you'd like to watch it. But this is a picture of Deepwater Horizon when it happened. Oil rig basically exploded and caught on fire and spilled, just thousands of gallons of oil into the ocean. And we are still cleaning it up today. So you can watch some videos on it if you're interested, but it occurred in the Gulf of Mexico. And one reason this was such a big deal is, as we just learned about, the Gulf of Mexico is what fuels what we call the Gulf Stream, a warm ocean current that goes past the U.S. up to Europe. So when this oil spilled in the Gulf Stream, one of the big deals was, can we get this contained so it doesn't get into that ocean current and get distributed worldwide? So 134 million gallons of oil spilled out to the Gulf. Is the biggest cleanup is from BP. That was the company, and it just cost, an insane amount of money, $30 billion, and it just had horrible effects on the wildlife that, again, we're still cleaning up. So 6% of the Earth's population lives in the U.S., and yet we use 30% of the resources on the Earth. That is a crazy number. 6% of the world's population are Americans, but we use 30% of resources. And again, why is that? Well, this is actually a very good thing, but the U.S. has a very high standard of living. Again, I've said this before, but what we consider poor is actually pretty well off by a lot of different countries' viewpoints. So we have access to more things than other people do. And so we should be very thankful for that. But as individuals, we need to be mindful and use things in a respectable way and not waste the resources that we so easily have, such as the food that we get, not just throwing it all away. Making sure you turn off lights and conserve your water, all that stuff is a big deal. Recycling, that is a huge way that we stop using up all these resources. But the question is, how long can these limited resources keep going for a population that is growing and increasing the amount of energy they use every year? So 81% of the U.S.'s energy comes from fossil fuels. But when the present supply of fossil fuels run out, that means we won't have any more energy. That means there wouldn't be, or at least the amounts of electricity and all those things would be drastically lower. You wouldn't be able to drive, all sorts of things. So that would be absolutely horrible if we ran out of these fossil fuels and didn't come up with an alternative. So that brings us to what a couple more slides. There's only enough coal to last us about 150 years. Now that seems like a long time, but this statistic is also very old. We've used a lot of it since then, so I don't know what the new number would be. But once we run out of these other fossil fuels, such as gas, there's only estimated about 50 years left. When that gas goes out, we have to use more coal, so that means coal would run out sooner. And so that those are all a very, very, very drastic, very quickly coming things. Now, what we're about to look at is the alternative, which is our alternative energy. We are running out of fossil fuels. Fossil fuels will not come back. If we do not have another resource to replace them, it would be drastic, very drastic changes for the way we live with no electricity. However, we are and have been researching alternative energies. They are already starting to be put in place. So it's not like we'll run out of energy and have nothing. We are trying to figure that out. That's just showing you why it's so important that we figure out alternative energy and we start putting it in place so that these 50, 52 years, that can be extended to hundreds of years, because the more renewable energy we use, the less of the fossil fuels, so the larger that number will become, which is very good. And that is what we will learn about in our next video.